Delaware Tech, Chemistry 100, Chemistry 110, pH calculations. So we've already talked about how to calculate pH from hydronium ion concentrations, otherwise known as proton concentrations. And we've talked about how to calculate pOH from hydroxide concentrations. We talked about the fact that the hydronium ion concentration times the hydroxide concentration equals 10 to the minus 14, or 1 times 10 to the minus 14 molar squared. And we talked about how pH plus pOH equals 14 always, as long as you're at 25 degrees centigrade. So I put all of those equations together in one little box of equations, what I call my pH rectangle. And this allows you to calculate any one of the four values from any one of the four values. We know that if we have this concentration, pH is equal to the negative log of that, and that, but following this arrow here, will tell us how to calculate pH. And using the formula here, this is just the inverse formula, so we can go from pH to hydronium ion concentration. Likewise, we can do the exact same thing with pOH and hydroxide concentration. The top equation allows us to go from hydroxide to pOH, and the bottom equation allows us to go from pOH to hydroxide, making sure you know how to use your calculator. Because we know that when we multiply this times this, they equal 1 times 10 to the minus 14 molar, well then, if I know this concentration, I can calculate this. And if I know the hydroxide concentration, I can calculate this. So that allows me to do that. And you're just going to follow the arrows. If you have this value, change that again. If you have this value and you want to get to here, you follow the arrow and it tells you what formula to use. So for those of you who have trouble with it, using algebra, especially with logarithms and powers and dividing by scientific notations, this is a good flow chart that lets you know how to do it. But you'll also notice, what if I gave you this? I gave you the concentration of the acid in the solution, and I said, hey, what's the pOH? Well, I have two possible pathways. I can either use this formula and then take my answer and use this formula, or I could take this formula and get hydroxide concentration first, and then using this formula, use the hydroxide concentration to get the pOH. So I have two different ways to go. I can either go this way, or I can go this way. And it really doesn't matter. If you're doing it correctly with the right functions on your calculator, you should get the exact same answer. But I'm going to give you a little hint as to which way is easier. These formulas are so easy. 14 equals pH plus pOH, or pH equals 14 minus pOH, that anytime you have a choice of going from one corner to the other, always pick the corner that has this easy pair of equations in it. It'll make your life easier. It's much easier to go this route than it is to go this route, because you're going to have to type this into your calculator. And most students find doing a simple subtraction so much easier than dividing with scientific notation numbers. So this is your flow chart. This is what you're going to use to solve everything, and this will allow you to go from any one of these four to any other one of these four. So let's look at some examples. What is the pH of a 0.0023 molar nitric acid solution? What is the pOH? What is the OH minus concentration? Okay, well, you'll notice I didn't give you anything to start with. I didn't give you the actual proton concentration, otherwise known as the hydronium ion concentration. I didn't give you that. What I gave you, however, was the concentration of nitric acid. What you need to know is that nitric acid is a strong acid, and that means that 100% of it will release this proton, and therefore whatever amount of this I started with, the second I put it in the water, I have the exact same amount of this in the water. All of this will be turned into this the second it hits the water. It's a very strong acid. It completely releases its proton. The proton will be bound up by water. So if I know the concentration of this acid, I know the concentration of hydronium ion, which incidentally is the same thing as the concentration of proton. Whichever way you want to write it for your personal notes, that's fine. So this is our hydronium ion concentration. And we're asked for pH, we're asked for POH, and we're asked for OH minus. And now we just use our formulas. Well, let me erase the notes here since they're clogging up. We know that the three are equal, and pH is equal to the negative log of that value, and that works out to 2.64. So our pH is 2.64. That's less than 7. That tells us it's acidic, which is what we'd expect because we just threw acid in the water. The POH is just 14 minus that value, so that's an easy calculation, and we get 11.36. A high POH means a high amount of acid. A high POH is low basicity, high acidity. It's always opposite of what you think. And so this corresponds. This is what you'd expect for an acid solution. Low pH, high POH. And then, now that we have our POH, we can use that to calculate our OH minus from our POH, or we could use our proton concentration. Remember, that's the same thing as our hydronium ion concentration, and we could use that directly to get our OH. So we can go either way to get our OH minus concentration. So what we've done here, I'm going to erase these notes for just a second and go back one slide. Remember, we started with this value, and at the end you were asked to get to this value. Well, you can either do it by getting to the pH first, or you can do it by getting to the OH minus first. And I showed you both ways, but I highly recommend this version. So let's go back here. All right, so let's look at the second problem. What is the POH of a 5.4 times 10 to the minus 5 molar solution of sodium hydroxide? And what's the pH, and what's the proton concentration, proton or hydronium ion concentration? Okay, so I've now given you the concentration of a strong base. So that tells you that all of it will be turned into hydroxide the second it hits the water. So that's the same thing. As if you have strong acids or strong bases, the concentration of those strong acids or strong bases will just directly translate into the concentration of your hydronium ion for acids or your hydroxide ion for bases. So we now know that value. And from that value, we can get our POH by plugging it into the minus log formula. And that gives us a POH of 4.27, a low number, which tells us high alkalinity, high basicity, which is what we expect because we threw base in here. The pH is the opposite. It's 14 minus that value, so our pH is high. That means it's a basic solution, which again is in line with what we know about what we made. And then finally, you can get the proton concentration by either using the pH, or you can get the proton concentration from using the OH minus concentration. Again, this way is probably going to be easier typing in the calculator, so I would go with that mode if you have the chance. And then the last equation says what are the hydronium ion proton concentration and the hydroxide concentration if the pH is 11.75. Well, the pH is very easy to calculate. It's just 10 to the minus that pH. The proton concentration is easy to calculate. It's just 10 to the minus that pH. And that gives us a concentration of about 1.8 times 10 to the minus 12. You'll notice that we only have two significant digits because of the 0.75, so our answer has to have two significant digits. I will tell you how many significant digits I want for this, so don't worry about calculating significant figures with pH. And the hydroxide concentration you can get from the proton concentration that we just calculated, and that gives us 0.0056 molar, a fairly large concentration compared to our hydronium ion concentration, our proton concentration, was what we expect, because our original number is a basic solution. That tells us it's quite basic. And just looking at these, this tells us it's also basic. And this pH, this pH here tells us we're quite acidic. So you can tell the pH or the pOH can tell you whether it's acidic, basic, or neutral very quickly. And you'll notice we have an alternate way, again, of getting the OH minus concentration. Now that we have this hydroxide, now that we have the pOH, which we could get very quickly from this value, it'll be 14 minus 11.75 or 2.25. We can plug that in and get it as well. So you have two routes again here to get your final result. And with that, we'll stop here.